So when we factored this, factored form gave us what on top? Okay. Over x minus 3 and x minus 1. Okay. All right. And there was a hole. Where was there a hole? X equals 1. Where was the x-intercept? Vertical asymptote and horizontal asymptote. Okay, so when we go to graph this, we start with our intervals. And on our interval line here, we put two things. We put our x-intercepts and we put our vertical asymptotes. So I had an x-intercept of -3, a vertical asymptote of +3. When I put these on the number line, in numerical order, which one's going to go on the left side? Okay. Yeah, I know, right? It's surprising information. So, and I put +3 on the right side. So my graph is really split into 3 intervals. Everything from -infinity to -3, from -3 to +3, and from +3 to infinity. So those are my intervals here. So I'm going to go ahead and fill those in on my chart. So -infinity is less than x, which is less than -3. -3 is less than x, which is less than +3. And +3 is less than x, which is less than infinity. And then I also need to write in my factors along the top side. So the factors were all 4 of our factors that we came up with. We include every single one of them. Even if they show up more than once, we still write it. Because it's important for us to have all those in there. Oops, sorry, that should not be a +3 there. That should be a -3 because I'm going in order of everything that was on. And on top, the numerator had x minus 3, didn't it? Was it +3 in the numerator?
Yes.
Oh, okay. So I was right then when I wrote it the first time. Okay. And then in the denominator, we had x minus 3 and x minus 1. So we're going to plug in different values in our intervals to decide, from our intervals to decide what is happening with our function on that interval. So I need a number. Please think carefully about this. I need a number between -infinity and -3. -4. Okay. People keep saying all day, yesterday and today, people are like, -2. I was like, no, that's not going to work there. Okay. So -4 minus 1 is going to produce what kind of number? A negative. And you do not have to write this out every time. I'm writing it out every time so you know what math I'm doing, but you don't have to write that, okay? And then -4 plus 3, that's going to produce what kind of number? Negative. And then same process, -4 minus 3, that's going to produce a negative number. And then -4 minus 1 is also going to produce a negative number. And again, it's not going to matter what number you pick in that interval. Any number between -infinity and -3, that's going to be true. Even if you pick -1,000, it's still going to produce negative numbers every time. And if I have 4 negatives, then overall, what's going to happen to that function? It's going to be positive. And we said yesterday that if it was positive, that just meant that it was where? Above the x-axis. So I'm going to go back over here to my interval line, and I'm going to draw a positive sign. And I don't know if you noticed, but when I draw those every time, I either draw them above the interval line or below the interval line, because that depends on if it's positive or negative. I'm doing that on purpose. All right, so that means from -infinity to -3, my graph is going to be above the x-axis. So I'm going to go ahead and go down here, and everything from -infinity to -3 is going to be somewhere in this red box. I'm not really sure where, but it's going to be somewhere in this area. Okay, so then we're going to repeat that process again for -3 to +3. Well, pick a number between -3 and +3.
2.
Can we pick 0? I always pick 0 when I can pick 0 because 0 is a really easy number to work with. Could you pick 2? Yes. It's going to produce the same thing, but I'm going to pick 0 because 0 is just easier to work with. So what is 0 minus 1? -1. So this one's going to be negative. What is 0 plus 3? 3, so it's positive. What is 0 minus 3? Negative. And what is 0 minus 1? It's negative. So looking at this row, what's going to be true about all these numbers? Or this function, it's going at this point, it's going to be negative. How do you know? What tells you? There's an odd number of negative signs there. So this function is going to be negative. So between negative 3 and positive 3, my graph is going to be below the x-axis. It's going to be in this range. So what's going to happen, out of curiosity, what's going to happen here at negative 3? It's going to cross over the x-axis. Does that make sense with what we've already found?
Yes.
Because what was negative 3?
X-intercept.
It was an x-intercept. At negative 3, we had an x-intercept. We had a point there. So at negative 3, my graph is going to cross over from the top of the graph to the bottom of the graph. Okay. So then from 3 to infinity, I need a number in between that interval. What's a number there? 4. Yeah, and don't be ridiculous. Don't pick numbers like 47. Like, there's no reason. Just like 4. It works. It does the same thing. So 4 minus 1 is going to give me something that is positive. 4 plus 3 is going to give me something that is positive. 4 minus 3 is positive. And 4 minus 1, positive. So that whole row is positive. So that means that our function is also positive on that interval. So it's going to be above the x-axis there. So I'm going to go and highlight that. So does this mean, out of curiosity, and you have to think about this in terms of the problem, does it mean that it's also going to cross the x-axis at positive 3?
Yeah.
Why not? You don't have an x-intercept there. Instead, we have an asymptote there. That's where our asymptote was. So we have a vertical asymptote at positive 3. And we also had a horizontal asymptote. Where was our horizontal asymptote? 1. Okay, I'm going to draw that in as well. And you guys should already have that drawn. Okay, so we've kind of got an idea of what our graph is going to look like. So let's start with the green quadrant up here. So I need my graph to hug my asymptotes that's in this green corner. So where could my graph be? It could be where? Okay, it could be on top of the horizontal asymptote. Technically, could it be between the horizontal asymptote and the x-axis? You're saying no. Why not?
Because it doesn't have to be in that quadrant, and then it can't be in the quadrant like adjacent to it. It has to be
Because it would have to.
Okay, if it was in this little bitty area here, then it would also have to cross the x-axis there, because it would have to hug up against this vertical asymptote. Well, it can't cross over because we know that it's not going to go down below the x-axis. So it is not going to be down there. It is going to be up here in this little bitty section. So it's going to look something like that. Okay. We have already decided that it's going to cross the x-axis at negative 3 because that's where our x-intercept was. So let's start with the red section over there. Where's my graph going to be in that red section? Below the whatchamacallit, below the horizontal asymptote. My graph actually just kind of exists right in here between the horizontal asymptote and that graph. So it's going to hug that horizontal asymptote. And we'll look at the graph on Desmos in a second, just kind of to prove that. So then what happens, we said what happens when it got to negative 3, it's going to do what? Cross over, and it's going to drop below. Don't draw this piece of the graph yet, okay? If you already have, that's fine, but don't draw it yet because there's one more thing we have to do with it. So I'm going to draw it. Just kind of observe what I do, and then I'll tell you when you can draw it, and you'll understand why I told you to wait. So it's going to come down, and, oops, that was not connected well. not connected well. Oh my gosh. Okay, so it's going to look something like that-ish, give or take. Okay, there's one thing about the graph that we have not even remotely touched on. The hole. Where was the hole at? At 1. That literally means whenever the graph crosses through positive 1, which would be, let's see, here's positive 1 for x. If I go down, it crosses right here. There is actually a hole in the graph there. You have to draw holes on there. Because holes are part of the graph. So you can draw this now. Holes are a part of the graph. And what we draw when we actually draw holes, what we do, yes, mine is white. You literally just draw a circle there to denote that there is a hole in that graph. That is how you show that. An open circle. Because we're saying at that point there's a problem with the graph. Like the graph doesn't exist at that one point alone. All right, so for our domain, so what's important about our domain, and some of this will make sense to you, is that our domain, oops, let's try a different pen there, does not include, what things do you think our domain can include?
The range.
The vertical asymptotes and the holes. Our domain cannot include the vertical asymptotes and the hole. So if we want to find the domain then for our problem, okay, do we have a hole in this graph?
Yeah.
Yes. What was our hole at? 1. So I'm going to write a couple things. I'm going to write this. First of all, I'm going to write it kind of in set notation-ish. I'm just going to write that x cannot be 1 because we're saying at 1 there's a problem. And where was our other problem? We said that also can't include our what? Vertical asymptotes. And our vertical asymptote was at 3. So those are the two values that can't be in our domain. So we're going to write an interval notation because we're just kind of practicing interval notation right now because that's the one that's newest of this year. So if I'm writing this in interval notation, I always start at what? Negative infinity. So I'm going to go along. Where does my first problem occur? At 1. My first problem occurs at 1. So my domain cannot include 1. So what is it that tells me that it can't include 1? What am I doing here? I'm doing a parentheses and I'm doing a union. So if it could include 1, what would I use instead? The square bracket. Square brackets mean that 1 could be included in that. So then what's my next interval going to be that numbers work on? 1, 2, 3. So everything from 1 to 3 is good. I can use all those numbers. 1.5, 2, 2.5, 2.6, 2.7, 2.8, 2.9. Those are all good. But I get to 3, and what happens at 3? Vertical asymptote. I can't use it. So I skip over 3, and then I start back right on the other side of 3, and I go all the way to positive infinity.
So in the middle, 1 to.
Okay, so for our range, I want you to find the range box on your page. And I want you to draw a line splitting it in half. And on the top half, I want you to write Bobo and Betsy.
Oh, my thing.
Because the triplets determine our range. The triplets help determine our range. Okay, what do Bobo and Betsy have in common that's different from Botan? They have a horizontal asymptote. So range is affected, or it cannot include our horizontal asymptote. So that's our restrictions on our range, is that it can't include our horizontal asymptote. Okay, so for our range for this problem, where was our horizontal asymptote? 1. So that means that y cannot be 1. So I'm just writing that y cannot be 1, but y can be anything else. So that means it could be anything from negative infinity to 1. What's going to come next? Union, and then 1 to positive infinity. So it can be everything but 1. And the reason, and we're denoting that it's not 1 because we're using the parentheses instead of brackets again. Okay, so the last part of this is under the Boba Betsy, I want you to write Botan. Okay, I want you to write Botan underneath there. So the difference with Botan is that you have to look at your local mins and maxes. With Botan, you have to look at your local mins and maxes. And we're going to look at an example in a second where you can see that. But you have to look at your local mins and maxes. Here's what I want you to know for your homework. I don't want you to find the range on these problems. If it's a Botan problem, if there is a slant asymptote, I don't want you to find the range.